Hello, we are from Group 7, and today we will be presenting our project on the topic of annual early childhood deaths. Before we dive into the details, let me introduce our group members. Nur Sayahinda, Nur Saheda Akila, Nur Nadia Vahida, Nur Azreen Aina. Our presentation will cover the following: introduction of the data, best fit quadratic curve, results, MAPLE, discussion, and conclusion.
We will be discussing a critical global health issue that remains a significant concern, which is child death. This metric not only reflects the overall well-being of a population, but also serves as a key indicator of the effectiveness of healthcare systems worldwide. Our project centers on analyzing annual early childhood death over the period from 2014 to 2023, utilizing a dataset sourced from the Department of Statistics Malaysia. The dataset provides the total number of early childhood deaths recorded each year. In this dataset, however, these categories have been combined into a cumulative figure presenting the total number of deaths for each year. For the analysis, a variable X represents time in years ranging from 1 to 10, corresponding to the years 2014 to 23. Variable Y represents the rate of early childhood death for each year.
In best fit quadratic curve, we have shown the calculation of least square solution, error vector, and magnitude vector.
For the least square solution, we have to use the normal system to solve the A transpose A equal to A transpose B. Matrix A is containing the independent variable in rows, which is times, and vector B contains the observed values, which are the rate of early childhood death. And then we have to compute the step of matrix A transpose multiple matrix A. The result will form the symmetric square matrix. We have to compute the transpose of matrix A multiple with the vector B, and we got the result, which are 81.7, 446.3, and 3118.7. This vector needed to solve the normal system.
So we got the answer for A, B, and C. So we can conclude that the least square solution has produced a quadratic equation representing the best fit curve for the given dataset, minimizing the sum or square errors between the actual data points and the model. The coefficient B and C control the linear and constant terms, respectively, shaping the graph position and slope.
We use MAPLE application to do the same calculation, and as we compare between manual calculation and MAPLE, we could see that MAPLE is easier and faster to get the results. We don't have to calculate and just insert the data and the formula to get the output. For the first step, you must key in the data first, and as I insert the times as A and the value of rate of death as B here. And over here, we just have to insert formula like I did here to get the reduced row echelon form of HW. The next step is a crucial one, since we have to insert the formula step by step to get the final result. I think MAPLE calculation is more easy since you don't have to waste your time but execute the calculation. Also, MAPLE eliminates the human error by performing precise calculation whether it is for smaller or larger dataset.
Next is error vector. To obtain an error vector, we need to use a formula E equal to B minus AX. After we implement that formula, we will get the list of the output. As we can see from the output, there is positive and negative value. You may be wondering why we need to find error vector. Actually, we need to find error vector to see the accuracy of the model. The smaller the error, the better the model. The list of error vector show that mostly the error are relatively small, but there are also some larger error. For the positive value, it means that the model are underestimate the observed value. Meanwhile, for the negative value, it means that the model are overestimate the observed value.
This slide shows how we calculate the magnitude error, which measures the difference between the actual values in a vector B and the predicted values from our model X. As the formula shown, this involves squaring each difference, adding them together, and then taking the square root. Here, we substitute the values into the formula, compute the squares, sum them up to get 1.8806, and finally take the square root, which gives us the magnitude error of 1.3713. So, these values helps us to understand how accurate our model is, with smaller errors indicating better predictions. So the conclusion that we got from the value of the magnitude error is the value is approximately 1.3713, which is relatively small, and then this suggests that the model provides a good fit to the data, demonstrating its accuracy and effectiveness in making predictions.
Is the calculation of the error vector and its magnitude using MAT523. The results are obtained very quickly despite the presence of a small error.
This is the result of the quadratic graph. The graph that is shown previously is a parabola that opened upwards, indicating that the death rate shows a declining trend. In addition, an improvement in conditions might have happened during the earlier year. For example, it might have better healthcare, policies, or interventions. After reaching a minimum around year 6, the death rate begins to increase slightly again. And this rise could indicate a reversal of positive conditions or the emergence of new challenges.